Hello, welcome to my extra credit gold points for Project Zero. This is a demonstration. So you can see a number of things. Let me just slow down the time real quick. Of course, the main thing is that I'm flying a spaceship around the screen. You can also see that there are these lines indicating the past position of objects flying around. This again just makes it clearer and easier to see what the orbits are. You can also see on the left some numbers. We'll look at them later. They basically show the velocity of the object relative to some fixed point. And you can see at the right now on the left it says relative to the sun. And by pressing P, we can change what that is calculated relative to. So let's go back to the sun. Yeah. Now we can also fly the spaceship by using the arrow keys, but right now, of course, everything is moving fairly slowly. To speed it up, we use the comma and full stop keys to adjust the time. So if we do that, we can see everything starts to move a bit faster. So this makes life easier when flying the spaceship. So now let's go and try to get an orbit around this Earth. Now, of course, it might be hard to see how can you get an orbit around the Earth. It's so small. And the trick is that we can also move the camera and zoom in and out and translate and do everything like this. Now you also notice in the background there that the spaceship just flew around the sun and is clearly affected by its gravitational field. And yeah, the spaceship inherits from the body extreme class, so of course it follows all the same physical behavior. So let's get in the orbit. So we use the arrow keys to fly the spaceship. You can see the velocity right now is fairly high, about 30 kilometers per second, but the time has been accelerated by several 100,000 times. So we'll still get to Earth in no time. So we're pointed there. Let's go move the camera, focus on the Earth. Mars is, yes, there in the background. Zoom in a bit. Okay, now let's try slowing ourselves down. So we can either slow the spaceship down or just slow time down temporarily. Now, once we get closer to a planet, it's kind of hard to keep working in the reference frame of the sun. So by pressing P a couple times, we can switch to working relative to the Earth, which makes life a lot easier. And so we can see now that the spaceship is in fact flying away from the Earth. So let's go and make an adjustment. And we can see now we're moving about 12 kilometers per second relative to the Earth, which is a decent velocity for a spacecraft. So let's just keep going. We're right now, how far away? 4 million kilometers away, whatever, something like that. We'll get closer quite quickly. And I'm just making some fine-tuning, adjusting the trajectory, and slowing time down again as we get closer and closer. We're now moving quite a bit faster, 15, 16 kilometers per second, so we can just adjust the velocity using the arrow keys again to try and slow ourselves down. And we can keep zooming in. Now, let's just stop time for a second to talk about some things. You might notice that as we zoom in, the planets in the spaceship all remain the same size. But as I keep zooming in, now the planets suddenly start to become larger. And so that's because when you zoom in far enough, the planet switches to displaying in the life-size mode. So that size is actually what a sphere of 12,000 kilometers in diameter looks like, if working in this coordinate system. And so let's just adjust the trajectory and bring ourselves around. Of course, we're still moving extremely fast and are in escape velocity, and are definitely past escape velocity. But notice that relative to the Earth, the velocity is going downwards, whereas we switch to relative to the Sun, like this, the velocity, let's just zoom out, is in fact in a different direction. And that's because, of course, the Earth's velocity has some effect in calculating the overall relative velocity. So let's keep going. Extreme accelerate time a bit, fine-tune trajectory, etc., etc., etc. Okay, so now we're at what? A height of about 9,000 kilometers. Our trajectory is clearly being bent by the Earth's gravitational field, and we're moving at almost 30,000 kilometers, 30,000 meters per second. So we now apply a retrograde maneuver, slow ourselves down to about 8,000 meters per second. And if we accelerate time again, we can see that our trajectory is now in a much sharper curve, and we have indeed achieved a somewhat elliptical orbit around the Earth. So orbit actually isn't too bad. Or maybe it's, yeah. So we're just passing through apogee now, going down. What we can do is reduce the height of the orbit again, and we can do that while at perigee. So let's just wait for the thing to swing around. You can see also that this purple light marker indicates the velocity of the object, velocity of the spacecraft, and its magnitude, although we can't see it here, shows the actual magnitude of velocity, but it also shows the useful approximate prediction of the object's immediate future trajectory. So let's slow the velocity down just a touch. Yeah, that should do it. Maybe a bit too much, in fact, to undo that. There. This might be a bit too low, but let's see. Yeah, a bit too low. Yeah, okay. So you can see here, there's no interaction between the spaceship and the Earth because I felt that was unrealistic. I mean, spaceships colliding the planet explode, they do not bounce. So if we just accelerate time, we can see now that the spaceship has achieved a reasonably tight orbit around the Earth, and that can be adjusted more. And you can see back here, the spacecraft is in fact still orbiting around the Sun. Everything is simulated correctly, the spacecraft obeys the same in-body dynamics as any other object in the system. We've seen that we can move the camera around, zoom in and out, how the graphics work, the velocity prediction, the controls, the time acceleration, the relative settings, and that's my extra credit. Hopefully it's good enough for gold points. Thank you very much for listening.